you have your radio on?
All right, looks like we got a couple people getting kicked today still. All right, hopefully they'll be able to join us. Yeah, I still haven't figured out why. I think it's the internet connection on your side. I'm not sure, but I noticed that every day there'll be one or two people that keep getting caught in this loop of like, hey, they want to join, I say accept, and then they just sit in limbo forever. Okay, Tim's here too. Okay. Let me let Tim in. All right, so welcome back, everyone. It is Friday. We are putting week 7 in the books of this distance learning, which is good news. We will hopefully be back in the classroom very, very soon. So November 4th, it's coming up quick. What is that, like 20 days or something, plus including the weekend? So that'll be nice. It'll be nice to be back. As I go through teaching all this electronic stuff, I just keep thinking, God, I wish you were in the classroom, because it's so much easier to teach and makes so much more sense when I can use the whiteboard and have you guys do projects right in front of me. So anyways, apologize for the confusion over the distance learning. I'm doing my best, but it's not nearly as good as if you were here in class. No, you will be starting class November 4th. So that's, I don't know, 20 days or so, give or take, something like that. I think it's, yeah, 3 weeks. And then the first week you come back, you're only going to be there for Wednesday, Thursday, Friday. So we have some kind of teacher trainings, I think, on Monday and Tuesday. Okay, let me pull up this, let me pull up the, where's my screen share? There it is. Okay, so let me pull up the notes here. The nice thing is we're actually getting close to being done with the notes too, so that's exciting, because once the notes are done, then we get to start moving into projects. So the cool thing is for you guys that basically as soon as you get back, we'll get a launch into projects. I probably have to do a refresher on the miter saw, because that saw could be dangerous and you're going to need it for the first project. But other than that, I think we should be able just to launch right in. Do want to go over and just do a quick review of some of these symbols, because I want them to stick in your head, okay? This is a foreign language, and it's very important that you kind of get the vocabulary in. So just kind of stick these in your brains, okay? Battery is that plus and minus, and it's the different sized lines. The longer lines are the plus, the shorter lines are the minus. And remember, each pair of those equals one what? Cell, okay, one cell. So remember that. So we can tell how many cells a battery is that way. And for like on your Xbox controller, a cell would mean how many AA batteries are in there.
2.
Hold on, I got a couple people adding. Let me throw them in here. Okay, sorry about that. Okay, all right. So we got the battery. The ground symbol, remember we're going to use the ground symbol as an alternative to the negative wire. The negative wire is normally our path back, but sometimes we're going to use ground. And just like I said on cars, it can save you almost half of the wiring requirements. So I wish we were here in class, I'd show you this. I have a great example for it. Unfortunately, over the internet, it just doesn't work as well. So I'll wait till we get back to do that. Okay, these are some of the most common symbols we're going to use, and we'll be doing a mapping of these probably right when we get back. We should do it before we get back, but I think it would be terrible to do it distance. So I'm just going to wait till we get back on that. So the bulb, very common one. It's got a little loop-to-loop, and then you draw a circle around it for the bulb. Remember, that's going to be a light bulb, not an LED, but it could be a fluorescent light bulb, or it could also be just a regular incandescent light bulb, which you guys probably haven't seen many of those because they're getting to be old technology now. Okay, resistors. Again, it's just that squiggly line. We use resistors a lot. Sometimes we use them at a specific number, and sometimes we use adjustable resistors. Okay, and then we've got our two circuit saving features. We've got our fuse, that's a one-time, remember? That's this S-shaped line here. That's a one-time use. As soon as it burns up, it's gone. And then we have circuit breakers that do the same thing, but they are reusable. Okay, what about this diode? Which way can the electricity flow on the diode symbol? Hopefully you said the direction that the arrow moves. That would be correct.
Facing that a vertical line.
Yeah, it goes whichever way the arrow's pointing, that's the way it goes. If it goes the other way and it hits that line first, then it gets stuck. Not to confuse you, but there is something called a Zener diode too. You don't have to write this down, but that one will only resist up until too much force, and then it lets electricity flow through it. So kind of a cool thing, but you don't need to learn that right now. Okay, let's see here if I can pull chat up.
What kind of application?
Diodes, actually, well, let me see if I could pull up one real quick. So somebody asked, why would we use a diode? Okay. See if I can, if this will be. Yeah.
I'm asking about Zener. I know you can make power supplies with diodes.
Oh yeah, Zener diodes are awesome, but they're a little more complicated than I want to get into now. So let's leave those till we get to them.
Okay.
So when you guys, so basically if we have alternating current coming in, we need to change alternating current to direct current. And so we can use a series of diodes to do that. So no matter which way the electricity comes in, if it's going to try to get back out, it will get stopped so that it will only allow the electricity to flow through one direction and creating direct current. I don't really want to get into the specifics of that because we're going to have a whole lesson on that later on. But for now, just understand that we can use diodes to clip off half of an alternating current to turn it into direct current. Okay, and we use diodes to do that.
How would you turn a direct current into an alternating current?
Using.
That's easier to do. So that one with direct current, it's usually electronically controlled, and we could easily just add branches to it. We could add waves to it, and we can change the hertz and the frequency. So those are all pretty easy to control digitally, but probably a little more complicated than what we need to talk right now. It'll make more sense as we get in there. So I don't want to skip this because I want to get to it today so we can get done with this part, because this is probably one of the more cool parts. So I want to make sure we do it. So just hold on to those questions. We will get to them. Okay, so now we've got an electrical circuit. Okay, in order to have a circuit, we need to have a couple of things. We need to have a power supply, we need to have a load, and we need to have a way to get the electricity there. So in other words, conductors. Okay, so we need a battery, which is our power source. It doesn't have to be a battery, but we have to have some kind of power source. We need to have conductors, and then we need to have a load. And the load is going to be whatever uses power. So there's three things we can do with electricity. We can make light, we can make heat, and we can make magnets. Okay, we can make motion using magnets. Okay, so that's the three things we need to have in our circuit. Now this one here is saying that we should have some other stuff, and we should, but those are not all required. Okay, like it says we should have a switch, that way we could turn it on and off in case there's a problem, which that's a good idea, and we should have a protection device to protect, in this case, the motor, but those are not required. Okay, they're good ideas, but they're not required. To have a circuit, all we need is a power supply, conductors, and a load, those three things. Okay, so now you got to write these things down, okay? These will be one of the more important things in the class when we talk about circuits. There's three types of circuits. So write these three down. There's series, there's parallel, and a series parallel circuit. So write those three down. Okay, so series, parallel, and series parallel. So let's start with the series circuit. These are probably the simplest, and they'll help us understand how a circuit works. Okay, so we said that a circuit needed to have three things minimum to work. It needs to have the power supply, it needs to have a conductor, and it needs to have some kind of load. So let's see if we can, if you can locate where the power supply is in this circuit. And type it in the chat if you know what the name of that symbol is right here. Okay, good. I'm starting to see battery, and yes, that's correct. That is the symbol for battery. Notice it's different than the other battery symbol that we saw before. This is like a picture of what an automotive battery looks like, and that's why it's used all the time. Okay, correct. It's battery without cells labeled. That's a really good, that's a very good definition right there. Okay, so this is a battery. It has an unknown voltage because there's no voltage listed on it, and it has an unknown amount of cells in it. Okay. All right, then we're getting to the next piece here, which is a fuse, and that's going to protect the circuit just in case something goes wrong. You know, maybe lightning hits the battery, or something shorts out and it's overheating and catching on fire. Okay, that fuse should protect the circuit from overcurrent. Okay, so if too much electricity is flowing through it, and remember electricity, the amount of electrical flow is current. So if too much current's flowing through, that fuse is going to blow. It'd be hard to recreate the circuit because there are no measurements. We could actually do this circuit. It will work with almost any size battery as long as it's big enough to power the light bulb. So we actually will make circuits like this. I have this one cool project I'm thinking of having us doing too, where we make our own light bulb. So I did a video on it, and I thought it'd make a cool class project too. So we might be doing that.
I actually did that this summer based off of the video.
Did you? It's really cool, huh?
Yeah, it was fun.
I always wanted to do it for years, and I just kind of forgot about it. And when we had that distance learning, I'm like, you know, that'd be a perfect time to try that. So I don't know. I might have us do it at home, or I might have us do it in the class, depending on time. So we'll see how it goes. All right, so far we've got our battery. We've got our circuit protector, which is a fuse, so one-time use. And then we come over to this thing, and anyone know what this one is?
That would be an open switch, right?
Oh, very nice. Good job. You nailed it. Yes, a normally open switch. How could you tell it was normally open?
Because the diagram left it open.
Perfect. That's exactly right. Since the diagram shows it open, that means it's a normally open switch. And you notice that symbol, I think we had switch up here, didn't we? Or did I not do switch yet? Maybe we haven't gotten the switch yet. We'll get to switch. I don't know where it is in here, but anyways. So this is a switch here. It's a normally open switch. And it's technically a single throw, single pole switch, okay? And it's normally open. You don't need to know that yet. You'll know it in the future. But so when that switch closes, it will allow electricity to flow through the load, which is the light bulb here. And then this light bulb connects to something metal. So this is a car. This is a diagram of a car's wiring symbol, okay? So it's gonna come out of the positive of the battery, because remember, we're using conventional theory. It's gonna flow through this switch. Sorry, it's gonna flow through this fuse. It's gonna get stuck at the switch until somebody pushes the switch down. Then it's gonna allow electricity to flow through. It's gonna go up to your dome light here. And then your dome light's gonna turn on. The electricity is gonna make its way back all the way to negative, okay? All the way back to negative. And this simple light bulb will light up. So I do want you to notice something, because this circuit actually has a ground instead of a return wire. So notice the light bulb here, it connects down to something metal on the car. Since the car is all metal, all we have to do is take a tiny little short wire and connect it to the metal of the automobile. And then somewhere in the car, we have to take the negative and connect one little wire from the negative to the metal of the car. And now every single circuit that we put on a car, all we have to do is touch metal somewhere, and it will return the electricity back to the battery. So really, really cool concept, and it saves us a ton of wiring. Okay, so in this case, it's called a ground, Because we don't have a negative wire, we have a ground path back, okay? So all of the circuits, like your headlights, your horn, your beeper, your indicators, your turn signals, your hazard lights, every single thing that has power in your car is going to go back to it, go touch something metal to go back. So in other words, all the metal of your car, like the body of it, has electricity flowing through it, okay? We don't get shocked because it has an easy path back to the battery. So it's going to follow the path of least resistance, and it's not going to try to jump through our fingers, okay? Yeah, we're actually going to be using all those, Cole. Capacitors, resistors, diodes. We're going to be wiring up all of those. That's part of the electronics portion of this class. We have a bunch of cool things in here, like all these breadboards where you can wire up circuits. And so I give you a bunch of tests like, okay, make this circuit that does this. When I turn on this switch, this light comes on. When I turn on this switch, these two lights come on. So we do a bunch of that kind of stuff in here. That's why I love this class. You get to do so many labs. Okay, so that was a series circuit. And the biggest thing I want you to know about the series circuit is there's only one path for electricity to flow, okay? And that's why it works. So if I open the switch, electricity cannot flow, meaning that the circuit is dead, okay? Now, this is the light bulb here. This is our load. And if you are gonna listen to anything today, listen to this. It's just such an important concept. I wanna know if that light bulb will turn on. Anyone want to make a prediction? Right now, the way the circuit's drawn, will that light bulb turn on?
No,
The switch is not.
it will
No.
not.
And
Yeah,
somebody
the switch is open.
good, the switch is open. Okay, so the way we can tell if this light bulb will light up is we're going to trace backwards, and we have to do two traces. And this is the fun part of electricity, because this is how you find all the problems. And like someone that's good at this will make lots of money because they could do it really quick. And electrical diagnostic work is expensive. It's usually $90 to $120 an hour, okay? So when you can find stuff quick, you can make a lot of money, because usually, like if you bring a car in, it's usually a 2-hour minimum. And so if you can find it in half an hour, you just made 2 hours of labor in half an hour. So this is why it's really good to be smart with electrical. Most people are not this good with it, okay? All right, so let's test this light. In order to test the light, we have to check two things. We have to check that it has a positive connection and it has a negative connection. If it has both of those, then the light should light up. What happens if the light doesn't light up and it has a positive connection and a negative connection and the light doesn't light up? What does that mean?
There's a short.
Nope.
Nope. There's
Switch is open.
no power. Or the
Nope.
light bulbs.
Neither of those are right. More guesses. You guys are going to be
Battery is
mad.
dead.
No, it's not the fuse. You guys are going to be mad when you come up with the
Didn't
Is
answer.
the battery dead?
Didn't turn
No,
it on.
not the battery dead.
The ground?
No.
Just give us a hint.
I did give you a hint. I gave you the answer. I said you have a good positive connection and you have a good negative connection. So both of those lead up to the light bulb, and the light bulb is still not working. Oh, Samar nailed it. Yes. The light bulb is burned out. Okay?
I
I said that.
The light bulb is burned out.
What? We said that.
Oh, I didn't hear you. Okay, so let's take a look at this. So people said like the fuse is burned or the switch is burned, but we know that cannot be true because we have a good connection all the way up to the light bulb. So if we have positive connection all the way up to the light bulb, then that means everything leading to it is good. So by having a connection here that's good, we have just tested every single other piece in that circuit. In other words, we're making big bucks because very quickly we just figured out that the whole positive side is good. By testing the negative side at the light bulb, we've assured that everything on the negative side is good. So we know this wire's good, we know the electrical ground is good, and we know that negative connection's good. Okay, so by doing that 2 quick tests right in one position, we've just determined that the whole circuit is good, and now we know that the light is what's bad. Okay, so whenever we test anything, we have to make sure that it has a positive connection and a negative connection. And if it does, then we know the little component is bad. However, let's just say I did something else. Let's say I tested the negative side. The negative side was good, okay? But I test the positive side at the light bulb here, and the positive side, there is no positive connection, okay? I'm not getting any positive electrical signals. So what could be the possible problems?
Battery's dead.
Okay, good. Battery
Fuse.
dead is one of them. Well, Suleiman, what'd you say?
I didn't,
Fuse.
I didn't even hear you. What'd you say?
Oh, okay. Sorry, I can't see everyone's picture, so it's hard to tell who's talking. So what else? Somebody said battery could be dead. Fuse is burnt.
What's the
That's
question?
also good.
What's the question?
Switch is up.
Switch is up, good. Or there's still two more things.
What's the question though?
We have a good negative connection, but we do not have a positive connection to the light bulb. What could be wrong?
Okay.
Frame is rusted is on the other side. We already tested the negative and the negative was good. So it cannot be in proper grounding either because the negative side all tested good. Wire broken, very good. Or burnt up or chewed through, very good, Samar. And then there's one last thing that could be wrong. So far we've got dead battery, we've got a fuse that's burnt up, we've got wire that's burned or broken, we got battery, that could be a problem. We already got it, dead or degraded, yep. Could be a bad connection at the battery. We got the battery. One more thing.
Fuse?
What's that?
Did we say the switch and the fuse?
Yes, the switch. So we could just have a bad switch too. It could be in the right position and it's just bad, okay? So good job. You're starting to see how this all works, okay? All right, well now let's go to,
What was the last one?
sorry, did you say what was the last thing?
Yeah.
So if there was a problem on the positive side, it could be anything. It could be the battery, it could be the fuse, could be the wire, or the switch. Could
I
be.
thought you said there was one more thing. Never mind.
I didn't hear what you said. I was talking. What was that?
I thought you said there was one more thing.
It was the switch. Nobody had said it was a bad switch. Somebody had said it was an open switch.
Okay.
So the last thing it could be is a bad switch. So even though it's thrown, it's still bad. Might be corroded or something.
Okay.
We'll do a lot of that stuff. It's really fun. I love it because you guys all get stressed out. I have a really fun test that I do with it, and I love watching you guys try to figure it out. I do all kinds of tricky things to mess you guys up. Okay, that's why you guys get good though. All right, so the next thing we're going to look at is an electrical schematic of the same thing. So the first one is more of like a picture, or they call it a pictorial drawing, and the second one is going to be a schematic. And this is the electrical language I was telling you about. And we're going to use symbols for this. So anyone remember what this symbol is?
Ground.
Ground, very good. What about this symbol?
Battery.
Battery.
How can I tell which side is the positive?
The long line.
Yeah, the positive is longer.
And I'll give you a cheat too. Here's a cheat method. What if you don't remember? Well, you can always look which one's connected to ground, and you know that's the negative side, okay? So how many cells are in this battery?
6.
6, very good. And this is an automotive cell, so they're gonna be like 1.2 volts per cell for a 12.6 total. Okay, what is this thing here?
Fuse.
Squiggly line, yep, it's a fuse. What's this thing here?
Open switch.
Normally open switch.
Good, normally open switch. And this thing here?
Light bulb.
Light bulb.
And what's this?
Ground.
Ground.
Another connection to ground.
Another ground. So here's an important thing for you to notice when you look at grounds. Even though there's no wire in between these two grounds, having a ground symbol means that it's touching ground. So I could have 18, 20, 100 wires all going to ground, and that's the same thing as them touching back here. So as long as I put the little symbol going to ground, then the whole circuit will be connected, okay? It will, like, the electricity will go from this ground to this ground and back to the battery. Dr. Frankenstein, I'm reading that book right now. It's a good book. Okay, so that was a series circuit. And the thing is, electricity only has one path to go. It has to go through it. So if this switch is open, no electricity is going to go. If this light bulb burns up, no electricity can go. If this fuse breaks, no electricity could go. Let's just do a quick map here. Let's see how this switch is up here. So we want to look at this light bulb. Does it still have a path back to ground?
No, not without the switch.
Wrong. It has a path back to ground. So we're going to look at the light bulb and we trace it to the ground. And remember, the grounds connect and then it will come back to the battery. So right now, even though this switch is up, the light bulb has a path back to ground. Does it have a path back to positive?
No.
No is correct. Good job. Okay, it's because the electricity is going to try to get back to the battery here, or I should say, it's going to try to get the electricity connected, but it's going to get stuck right here, right? So there's no way for this light bulb to connect. Okay, so whenever we check something, we have to have a path of positive back to the battery and a path of negative back to the power source. Okay, so we have to have both. We have to have the positive side and the negative side. All right. Next up, oh, actually, I'm going to kill it there because we're out of time for today. I will see you guys on Monday. Good job today. And you can see how this stuff starts to get really fun now. Next step, we'll do parallel circuits, and then it has all kinds of paths. Okay, so I'll see you guys tomorrow or Monday. Have a good weekend.